So the three functional types of oral mucosa are lining, masticatory, and specialized mucosa. These terms provide functional descriptions of the oral mucosa in specific locations. 1. The masticatory mucosa covers the gingiva and hard palate. It has epithelium that it has a keratinized and parakeratinized stratified squamous epithelium. It has lamina propria, which is two layers, a thick papillae layer of loose connective tissue and a deep reticular layer of dense connective tissue. And the lining mucosa. So masticatory has epithelium and lamina propria, and lining mucosa has epithelium, lamina propria, submucosa, and specialized submucosa. So the lining mucosa covers all of the soft tissues of the oral cavity except for gingiva, hard palate, and dorsal surface of the tongue. Its epithelium, generally, the epithelium of the lining mucosa is non-keratinized. On the vermilion border of the lip, however, it is keratinized. If subject to unusual friction stress, the epithelium may become parakeratinized or keratinized. Other cells found in the epithelium of the lining mucosa are Langerhans cells, melanocytes, and Merkel cells. Now, the lining mucosa also has a lamina propria, which under the epithelium of the lining mucosa, a loose connective tissue with thin collagen fibers forms a papillary lamina propria that carries blood vessels, lymphatic vessels, and nerves. It also has a submucosa. The lining mucosa also has a submucosa, which is a distinct submucosa that underlies the lining mucosa, except on the inferior of the tongue. Okay, so the submucosa is distinct submucosa that underlies the lining of mucosa, except on the surface of the tongue. I mean, on the inferior surface on the tongue. The submucosa contains large bands of collagen and elastic fibers that bind the mucosa to the underlying muscle. Okay. The submucosa also contains the larger nerves, blood vessels, and lymphatic vessels that supply the neurovascular networks of the lamina propria throughout the oral cavity. In the lips, tongue, and cheeks, the submucosa contains many minor salivary glands. And it also has specialized mucosa, which is restricted to the dorsal surface of the tongue and is keratinized by the presence of surface papillae of several types and by taste buds in the epithelium. The epithelium is keratinized. Important: all oral mucosa, whether keratinized, non-keratinized, or parakeratinized, is of the stratified squamous type of epithelium and the underlying central core of the connective tissue. Although the epithelium is predominantly cellular in nature, the connective tissue is less cellular and composed primarily of collagen fibers and ground substance. Again, although the epithelium is predominantly cellular in nature, the connective tissue is less cellular and composed primarily of collagen fibers and ground substance. So epithelium is predominantly cellular in nature, and connective tissue is less cellular, but it has more collagen and ground substance. Now, on the facial surface of the mandibular canine, in the first premolar and lingual surface adjacent to the mandibular incisors in canines, that's where you will find the narrowest band of attached gingiva. So the question is, where is found the narrowest band of attached gingiva? Again, the narrowest band of attached gingiva is found in, so answers are on the lingual surfaces of maxillary incisors and the facial surfaces. Okay, again, forget that. The narrowest band of attached gingiva is found, and the answer is on the facial surfaces of the mandibular canine and first premolar. And the lingual surfaces adjacent to mandibular incisors in canines. Narrow gingival zones may occur also at the mesio-buccal root of maxillary first molars. Mesio-buccal root, which is the buccal for mesial root, that is on the maxillary. It's associated with prominent roots and sometimes with bony dehiscences and at the mandibular third molars. The width of the attached gingiva is determined by subtracting the sulcus of pocket depth from the total width of the gingiva. Again, the width of the attached gingiva is determined by subtracting the sulcus of pocket depth from the total width of attached gingiva. This is done by stretching the lip or cheek to demarcate the mucogingival line while the pocket is being probed. The amount of attached gingiva is generally considered to be insufficient when stretching of the lip or cheek induces movement of the free gingival margin. So again, the question is the narrowest band of attached gingiva is found, and remember that attached gingiva is what you have from the from the total width of gingiva from the mucogingival line to the gingival margin minus the pocket depth. So that's how you're going to determine the attached gingiva. So the attached gingiva is less in these areas. This is done by stretching the lip or cheek. Okay. The width of the attached gingiva is determined by subtracting the sulcus of pocket depth from the total width of the gingiva, which is the gingival margin to mucogingival line. This is done by stretching the lip or cheek to demarcate the mucogingival line while the pocket is being probed. The amount of attached gingiva is generally considered to be insufficient when stretching of the lip or cheek induces movement of the free gingival margin. The width of the attached gingiva on the facial aspect differs in different areas of the mouth. It is generally greatest in the incisor region, which is 3.5 to 4.5 millimeters in maxilla and 3.3 to 3.9 millimeters in the mandible. Why? Why Why is it the greatest here? Because the mucogingival line is high and the pockets are generally small. So if you remember that the width of the attached gingiva is determined by the size of from the mucogingival line to the gingival margin minus the pockets, then you'll have 3.5 to 4.5, and in the mandible 3.3 and 3.9 in the incisor regions, okay? And the narrower of the posterior in the posterior segments will be 1.9 and 1.8, 1.9 being in the maxillary and 1.8 in the mandibular first premolars. Why? Because in the mandibular first premolars, the mucogingival line is high, the gingival margin is low. Important, a functionally adequate zone of gingiva is defined in as one that is keratinized, firmly bound to tooth and underlying bone, about 2.0 millimeters or more in width, and resistant to probing and gapping when the lip or cheek is distended. Note, again, let's read that again. An important adequate zone of gingiva is defined as one that is keratinized, firmly bound to tooth and underlying bone, and 2.0 millimeters or more in width, and resistant to probing and gapping when the lip or cheek is distended. Notes. Two notes. Number one, the attached gingiva is structured to withstand functional stresses of mastication and brushing. Again, the attached gingiva is structured to withstand frictional stresses of mastication and brushing. And note number two, the alveolar mucosa appears to be well adapted to permit movement, but is not able to withstand frictional stresses. Next, at least 2/3 of the inorganic component of calculus is crystalline in structure. Of the four main crystal forms, which one is the more common in the mandibular anterior region? Again, at least 2/3 of the inorganic component of calculus is crystalline in structure. Of the four main crystal forms, which is more common in the mandibular region? Answer is brushite. Supragingival calculus consists of inorganic 70 to 90% and organic components. The inorganic portion consists of 76% calcium phosphate, 3% calcium phosphate, and traces of magnesium phosphate and other metals. The principal inorganic components are calcium, phosphorus, carbon dioxide, magnesium, and trace amounts of sodium, zinc, strontium, bromine, copper, manganese, tungsten, gold, aluminum, silicon, iron, and fluorine. At least 2/3 of the inorganic component is crystalline in structure. The four main crystal forms are as follows: hydroxyapatite, which is 58%, magnesium with locite, 21%, octacalcium phosphate, 12%, and brushite, 9%. These are the main crystal forms, which are 2/3 of the inorganic component in crystalline structure. Generally, two or more crystal forms are typically found in a sample of calculus. Hydroxyapatite and octacalcium phosphate are detected most frequently in 97 to 100% of all supragingival calculi. Hydroxyapatite and consists in the bulk of the calculus. Brushite is more common in the mandibular anterior region and magnesium with locite in the posterior regions. So, again, the organic component of supragingival calculus consists of a mixture of protein, polysaccharide complexes, desquamated epithelial cells, leukocytes, and various types of microorganisms. The composition of subgingival calculus is similar to that of supragingival calculus with some differences. Subgingival calculus has the same hydroxyapatite component, more magnesium with locite, and less brushite and octacalcium than supragingival calculus. The ratio of calcium to phosphorus is higher subgingivally, and the sodium content increases with the depth of perilumbal pockets. Salivary proteins present in supragingival calculus are not found subgingivally. Calculus is both supragingival and subgingival and is located on interproximal surfaces that can be seen on bite wing radiographs as interproximal spurs. So brushite is more common in the mandibular anterior region and magnesium with locite in the posterior regions. So that doesn't mean that brushite is the most common in all, it just means that it's more common in anterior region.